Hello everyone, Assalamu alaikum. In this project you will learn how to control the brightness of an LED using PWM. So let's get started. So let's go to Mini Project 4, click on it. So here we go. LEDs can be used for on and off lighting system, but they can also be used for applications where the light intensity can change. So in this project you will learn how to change the intensity of the light. So what are you going to use, or what will be the project outcomes? You will use analogWrite to control the brightness of an LED, and you will use for loops to gradually increase and decrease the LED brightness value. Okay, so let's go to Tinkercad. So of course, if you don't know how to use the Tinkercad, you can go back to the previous videos. I explained in detail how you can enter your ESIS number and join the Tinkercad, or you can have your own account there. So you will go to circuits, then create new circuits. So first of all, you need to build the circuit. Okay, you need to build the circuit, and then we will start from there. So what you will need: LED, resistor, and wires. Of course, in this case, you can use a breadboard, but I think it's very simple connection here, so no need for the breadboard. So let's build the circuit. Go to Arduino. You can use any of them. So you can use the fade. So let's drag it here. Or you can start your own project by dragging Arduino, then LED, then a resistor. We have been through the steps before. So to make it quickly, let's just drag this, go to code, go to text, click on continue, then delete everything written here. Let's go to our code. You can copy it from here, or you can copy it from the Arduino file here. So it's up to you. Let me copy it from here, so to avoid any mistake, because sometimes when you copy from here, some of the signs you need to do it yourself, or it will give you an error. So click OK, click no, and then copy everything, then go to here and press it. Okay, so let's start with the connection. So the LED is connected to pin number 9. Also in the fade project, which I dragged here, yes, it is connected to pin number 9, so no need to change. If you want to change, you just click on the wire here and then drag it wherever you want it to be connected. So in this case it's correct. Of course, if you want to change the color, you can change it from here, orange or any color you want. Okay, so let's start the simulation and let's see what is the outcome of this project, and then I will explain in details how to do it. So as you can see, the brightness go up to its maximum, then decreased, then increase, then decrease till it's go off. So as you can see, this is the output here. Let's stop the simulation and let's go step by step on how do we make this code. Okay, so first step here is to connect your LED, and we have to write in the code where did you connect your pin, or where did you connect your LED, in which pin did you connect it. Okay, so in our case we connected the LED in pin number 9, and we connected in the digital pins, right? So here I need to point something very important, that when you want to control the brightness or the speed or the level of the voice, so when you have a multiple outcome, So in this case, you use the pins where you have this sign, which is the PWM signs. What is PWM? It is a pulse width modulation. I will go into details on what this means. But here in this step, I just need you to understand that there are 6 pins where there is the feature of pulse width modulations. 3, 5, 6, 9, 10 and 11. Those are the pins where you have this feature. Okay, and of course here is the input. In our case, the LED, as I told you, the LED is output, so it will be connected here. And in which pin exactly? Though, for any pins where you have this sign, the pulse width modulation. So the second step in the void setup, you need to write the pin mode for every digital or analog pin connected. In our case, there is only one pin connected, so there should be only one pin mode function. Okay, so the pin mode here, then the pin name, which you identified it in the first line here, then you decide whether it's output or input. So how to decide that? As I explained before, if you are going to use your hand like a push button or a potentiometer, or if it will collect a data to the Arduino like sensors, it will be input, and it will be output when you have the outcome. So you can see the light, or you can hear the voice, or you can see the speed, so the result like LED, motor, buzzer. So in this case, the pin mode function, then the pin name, which we write it and declare it here, so we will put it the same, LED, then comma, then it is output, so we use this one, we write it here. Don't forget that output and input here, they are both in capital letters. All of the letters are in capital since it's in red here. Okay, and in the pin mode, everything here is small letter except the M letter. Okay, so now let's go to the void loop function. So this is the void loop, everything here inside the void loop. So there is a curly bracket here and it's closed here. Okay, as you can see. Now what will be the next step inside the void loop? So as we define the pin here, it's output and its name is LED. Now since it's an output, I need to use the write function. If it's an input, I need to use the read function here. So there is 2 types of output, analog and digital. Okay, and both we use the write function. So let's see what we have to use in this case. So first of all, we used to use the digitalWrite function if we are controlling the light, if it is on or if it is off, if we want to turn it on or to turn it off. If it is on, we use high. If it is off, we use low. But in this project here, we need to control the brightness of the LED. So by logic, you need to have multiple data to be controlled. So you want to see the LED when the brightness is full, then middle, then no brightness at all. So in this case, we need to use the analogWrite function. Okay, so the analogWrite function, first thing you need to know about this analogWrite function, this analogWrite function has nothing to do with this analog inputs here. It has nothing to do with the analog pins here. Why? Because this one is for the inputs. The analogWrite is for the output. That's the first point you need to know. The second important point you have to put in your mind when dealing with analogWrite is that you have to use specific pins only. Which pins exactly? So only the digital pins where this sign is there, which means that they do have the PWM feature. Okay, so this is the second point you need to understand. So you will ask maybe why I connected to a digital pin if it is analog, right? So in this case, you have something called pulse width modulation. The pulse width modulation is acting like a gateway between the digital signal and the analog signal. So analogWrite, we have to write the pin name here. The pin name is the same, which is LED pin. Okay, then we have to write here a value. The value here in analogWrite, it's not on or off like the digital write. No, here we have multiple data. So for the Arduino to understand it, we need to give it a minimum value and a maximum value. Okay, so how you can understand this? So basically 0 volt and 5 volt is the maximum output that the Arduino can give. Okay, so the 0 here is representing the 0 to be here, the 0 value. So 0 value here means that the LED is off, so no power at all. 0 volt mean no power, means 0 here, the LED is off. Okay, the maximum value we can put here is 255, which means the maximum volts that the Arduino can give to the electronic, which is if it is LED or if it is buzzer or motor or whatever. So 250 here is the maximum power that the Arduino can give to your connection. So to have the maximum power or the maximum brightness or the maximum speed or the maximum level of voice, you need to use what? The 250 here. Okay, and in between, of course, you can change the value gradually. So let's have a devlog here. So as you can see, 0 and 5 volt, as I told you, the Arduino can give from 0 to 5 volt. Okay, 0 means no power at all. 5 means the maximum output. So for the 5 volt here, it's 255, which you can put here. Okay, so if the value here is 0, the value here is 0 like this, 0, this means there's no light, no brightness at all. Like if there is a buzzer, no voice at all. Okay, if you increase it 25%, which is 25%, which is 64 for example, the voice will be increasing a little bit. And then if you increase it 50%, it will be 127. The voice will increase, the brightness also will increase, and then you can add it or increase it gradually till you reach the full duty cycle, which is 255, which is the maximum brightness and the maximum speed or the maximum voice. Okay, so let's not use the for loop. Let's just use analogWrite separately. So analog, the write in capital letter, the W in capital, and then I have to open the bracket, and then I need to control what this LED, which I identify it here, right? So copy, paste, and then, so I told you here, so we do have a value from 0 to 255 when I'm using the analogWrite, right? So from 0 to 255. Let me write here 0. What do you think will happen here? Let's start the simulation. Oh, I forget to put the semicolon here. Okay, let's start the simulation and see. What do you think will happen? Exactly, there's no power here because this LED gives 0 power. So the LED is not, so this Arduino is giving 0 power to this LED. So that's why there's no power. So it's, as you can see here, it's off. Let's stop the simulation. Let's give it the maximum value, which is 255. Let's start the simulation. What do you expect? See, it's full power, maximum power here. Okay, let's stop the simulation. Let's make it here 100. So what do you think? The brightness will be less. See, the brightness is less. So now let's try a number out of the range. So the range here is from 0. So the range here, as you can see, is from 0 till 255. So I keep saying 250, but I mean 255, okay? So 255, this is the maximum value, and 0 is the minimum value here. 0 off, and 255, which means the maximum power, the maximum brightness, the maximum speed. So here, let me try if I put 256, for example. So 56 here is out of the 255 range. So let's see what will be the output here. So what happened? As you can see, it's like the code is not working. Why? Because 256 is not recognized by the Arduino here. The Arduino only recognizes the value of the analogWrite to be from 0 till 255. So that's it for the understanding of the analogWrite function. Now let's move to our code. We use the analogWrite, and then we want to control the LED here, so we put it here, and then here is the brightness. Okay, for the brightness, since we need to increase it gradually, we first start with integer int brightness equals 0. We use the for loop here, and then we increase it every time by 5 till we reach brightness less than 255. Okay, and each time we increase, there is a delay of 50 milliseconds here. Okay, so for this we reach the maximum value, which is 250. After that, we use another for loop to decrease the brightness till we have no brightness. So in this case, we start with the brightness 255. So when it reaches 255, we need to decrease it each time by 5 till we reach brightness 0. And then every time we decrease by 5, we have a delay 50 milliseconds here. So the delay function here, is the time we set for every step. Okay, so here 50 milliseconds, and this will go in a loop repeatedly till I stop the simulation. Let's start the simulation and see. After we understand the logic, it's increase and then decrease and then increase and then decrease. So this is how we control the brightness here. So now let's go for further exploration. Change the delay in the code to make the LED change brightness at a slower rate. So we want the LED to change its brightness at a slower rate. What do we have to change? The delay function. So here is our code. So they ask us to change the delay function to be slower. So if we want it to be slower, That's mean that we need to increase here the delay, the time of the delay. Why? Because slower means that you need more time, right? So we need to increase here the delay function. So let's instead of 50, let's give it extra 0 here, and let's see the result here. Start the simulation, and let's see the brightness here changing at a slower rate. So as you can see, it takes longer time to reach its maximum, and then when it's reached its maximum, see, it will go now down till it reach 0, till it be off. Okay, so now let's go to the second question. Reset the delay back to 50. Edit the parameters of the for statement to make the LED change brightness at slower rate. So let's go to our code. Let's put this back to 50. Okay, now we need to change the parameter here so it will change at a slower rate. So what do you think we have to do here? In this case, we need to so every time here it changed by 5. It increased every time by 5, by 5, by 5, by 5 till it reach 250. Okay, so to make it slower, instead of 5, let's make it 1. Right? So if we make it 1, so every time it will increase only 1 till it reaches 250, and here it will increase every time by 1 till 0 here. Let's start the simulation and see the result and how it becomes slower. So see, it's taking time to reach its maximum value here. Now it's reached to its maximum value. Now it starts to decrease, and see, it's taking time, because each time I need to increase by 1 to reach the maximum, and then each time I need to decrease again by 1 to reach its minimum value. Okay, so now let's go for the last question. Now connect the LED to pin number 7, a non-PWM pin. Remember to change the statement from 9 to 7. Then what did you notice? So now let's go there. Stop the simulation. Now we have been asked to change the LED from here, so as I told you, if we need to control the brightness or a speed or a voice, if you have multiple data, we need to connect it to the PWM pins only. So those PWMs is where you need to use the analogWrite. So again, the analogWrite has nothing to do with the analog pins here. The analogWrite has always something to do with the pulse width modulation here. Okay, with this pulse width modulation pins, which has this sign. Okay, so now let's move this pin, LED pin, from 9. Just click on the wire here, take the circle and put it in pin number 7, and also change here to pin number 7, and let's see what will happen. So let's start the simulation and see what will happen. So as you can see, the LED is blinking. So it's go on for a while, then go off for a while, and then again go on for a while. So as you can see, there is no gradually changing in brightness. It's only on or off, and that's it. Why? Because this pen has nothing to change with the pulse width modulation. It's only 1 or 0, on or off. So that's it. So of course, don't forget to click on here and add the name of your project and your name and your class. So mini project for your name and your class. Good luck.